This video has been made to present the process of assembling, riveting and launching of open web girder of size 1 into 7.620 meter span at bridge number 16 over Madhopur Barrage left canal in connection with Cantt-Jammu Tawi doubling of work. The prefabricated parts of the girder components are transported from bridge workshop to the site of the bridge. The available prefabricated calendar Hamilton span (CH span) is used as the launching nose to save the cost of the launching material. First, the sandblasting is done at site to achieve surface roughness as per ASTM level of SA 2.5. After sandblasting, metallizing is done with 99.5% pure aluminum wire with coating thickness of 150 micron. After applying aluminum coating, coats of wash primer, zinc chromate primer, aluminum paint is applied to the girder. Each layer is applied with approved quality of paint to maintain color, viscosity, consistency and scratch hardness. The metallized girder components are assembled on ground by putting CC cribs at main joints and are jointed together by using minimum 60% filling of rivet holes with bolts and drifts. First, the bottom members are joined using temporary bolts. Then vertical and diagonal members, top chord members, end reckoners are joined respectively. The partially assembled girder is put on camber jacks in such a way that the designated camber of 94 mm is available. As the assembly proceeds, the bolts and drifts from previously joined section are removed and replaced by permanent rivets. All side drive rivets are tested and defective rivets are replaced with the good ones. Total of 21,400 20 by 22 mm diameter field rivets are to assemble this girder in addition to the shop rivets. Being an open web girder of 250 feet span, having 330 metric tons of weight and launching height of 10 meters, it is decided to launch this girder by end launching method. On the approach of each abutment, CC crib stacks is prepared with the help of hydras and clamped properly to reduce the length of cantilever during the launching process. An 80 track of 5,400 mm gauge is laid over the CC crib stacks and below the length of the girder to allow movement of the girder and trolleys. Concrete base, wooden sleepers and 60 kg rails are used to make the 80 track. The girder along with the launching nose is raised using hydraulic jacks below the predetermined nodal points, and the trolleys are inserted so that the girder can be moved over the inserted trolleys. The launching nose and main girder is joined together with the help of designed link members to act as a whole. Mock test for deflection is executed at the ground for a length of 61 meters, over which the girder is to be launched. Deflection test was found successful and the behavior of link members was also satisfactory. 4 winches, 2 on each side of the canal, are used for pushing and pulling the girder. Each winch has a capacity of 10 metric tons. Each winch setup is founded on a concrete base foundation with the HTS wire laid inside the foundation to be used by clamping the winch. The winch is anchored to avoid overturning during pulling and pushing of the girder and launching nose. The pulling and pushing starts simultaneously on both sides. As the trolleys allow the movement of the girder, RCC blocks are placed on the rear side of the girder frame to act as a counterweight. As the trolleys under the rolling arrangement complete their path after passing of the CC crib stack, trolleys are detached manually with the help of crane. As the launching nose reaches on the other end of CC crib stack, again trolleys are inserted below the nose so that the previous overhang portion again starts working as a beam. When the launching nose reaches the other side, it is dismantled in parts till the main girder reaches on the other abutment. The link member is then unfastened. Now there are only 2 trolleys remaining, 1 on each side. Hydraulic jacks are used to lift the girder and trolleys are removed, and the girder is lowered on the rocker roller bearings. Then the track is laid on the girder by using channel sleepers and is made functional for running of trains. This bridge is being constructed to facilitate the doubling of Pathankot-Jammu Tawi section of Firozpur division between Madhopur, Punjab and Kathua stations of Northern Railway.